Hello everyone, we are Group 5. Today we will present our MCP1 project. Boeing 737 MAX crisis breaking the chain of safety values. We'll talk about Boeing's organizational challenges, specifically how weakness in its control system allowed critical safety risks to remain unresolved. In less than 6 months, between October 2018 and March 2019, two brand new Boeing 737 MAX aircraft crashed. We can see two pictures. One is Lion Air Flight 610 and Pennsylvania Airlines Flight 302, taking 346 lives. There were no isolated accidents, but symptoms of deeper organizational values, a toxic culture that slimed safety concerns, incentives and rewards speed over safety, poor cross-department communication, and neglected pilot training. So in this presentation, we will propose two actionable recommendations to prevent such control values in the future. First recommendation, establish a cross-departmental safety oversight committee. Forward, we propose a four-process closed-loop management system. This system integrates three control types and covers the entire life cycle of aircraft department, from design input all the way to post-accident optimization. Our goal is to establish a prevention response interaction safety management system. It aims to prevent risks at the soil and control risks in the rail, time during execution enhancing overall aviation safety.
The following outlines the people, timing, and location for Recommendation 1. For the people involved, during the input phase of feed-forward control, the cross-departmental pre-research team is key, composed of engineers, safety officers, certification bodies, and others. They work together to check that designs follow the rules. Enterprise management level approve the risk manual and veto plans for carrying out the work. During the concurrent control phase of the process, the cross-departmental safety oversight community joins in. Its members come from engineering, safety, and other departments. Risk disposal specialists keep a real-time dashboard to follow how 48 hours discussions are going. The HR departments connects how well risk management works with performance reviews and gives rewards or penalties. In the feedback control phase of the results, an accident review team led by senior management's work with safety, legal departments, and people from outside who check what happened. The process optimization teams turn what was learned into a negative exit list and changes the rules for giving feedback. In terms of timing, the feed-forward control in the input phase need a cross-departmental pre-research team to be formed and a risk escalation manual to be made before new aircraft development starts. Checks to make sure core designs follow the rules must be done before important design solutions are finally decided. Concurrent control in the R&D testing phase needs weekly meetings where different departments share risk information. The risk dashboard is updated in real time, and if a risk warning goes off, meeting must start right away. In the feedback control phase of the results, after a safety accident or big failure, a review of what happened must start right away, and a list of short-term fixes must be put out. The negative exit list must be changed before work starts on the next generation of aircraft. And the place can be a meeting room, using a mix of online and in-person.
For costs in the feed-forward stage, costs include salaries and training for the pre-research safety team, extra simulations and testing to verify design safety, and preparing compliance, documentation, and reporting systems. These steps help prevent high-risk features, such as single sensor dependency in the MCAS system, from reaching production. For concurrent control, expenses cover running the cross-departmental safety commit, building and maintaining the system-wide risk dashboard, and managing coordination with industry regulators to keep safety standards on track. In the feedback stage, costs come from post-incident investigations, knowledge management tools, and tracking systems to ensure problems are addressed promptly. For potential problems, for feed-forward control, Possible issues include longer approval timelines that slow innovation, disagreements over what counts as high risk, and flawed decisions if safety data is incomplete. In concurrent control, risks involve cultural clashes between departments, poor information flow, and information overload delaying urgent action. Even with fines for delays, Boeing may still see limited improvement in compliance. In the feedback stage, reviews might be too superficial to find root causes, often relying on negative lists instead of fresh analysis, and risk creating a blame culture that discourages open reporting. By identifying these costs and anticipating these risks, Boeing can strengthen its safety oversight committee while avoiding new operational barriers.
Now I will discuss the recommendation 2. The topic is implement an integrated safety governance framework. The first part is what to do it. Establish an integrated safety governance framework combining early-stage technical audits, real-time safety monitoring, post-incident learning. So friendly applied across all departments for every new aircraft system. The second part is steps that need to be carried out. The first one is early technical audits. It's about feed-forward control. Before design approve, conduct independent reviews involving engineering, safety, pilot training, and compliance teams. Reject all re-engineer unsafe designs, such as those with single sensor dependency. Publish a risk escalation manual with defined reporting rules and response timelines. The second one is real-time safety monitoring. It's about concurrent control. Create a centralized monitoring platform integrating live data from sensors, test results, and pilot feedback. Trigger cross-departmental review with 48 hours when analyze outcome. Link resolution performance to staff evaluation and impose penalize for delay. The last one is post-incident learning. It's about feedback control. Within 30 days of incidents, conduct root cause analysis and update the prohibited design practice list. Incorporate lesson into future design, training, and audience procedures. The last part is who does it. Led by the Chief Safety Officer, involving engineers, safety officer, pilot training leaders, compliance teams, and independent third-party safety auditors will do it.
This timeline shows when and where a safety framework will be applied. It starts from the very first concept of the aircraft and continues all the way to post-delivery options. At 4 key stages: design approval, prototype testing, production, and post-incident review, we conduct systematic safety checks. This ensures risks are caught early, monitored during development, and reviewed after delivery, creating a continuous loop of safety improvement. This outlines the main costs of implementing our safety governance framework. First, auditor fees will cover independent safety reviews at each stage. Second, we will invest in an IT platform for real-time monitoring to detect issues as they arise. Third, training and workshops for cross-department teams will ensure everyone understands the safety protocols and can collaborate effectively. These costs are investments that will lead to long-term safety and efficiency gains. Here are the potential problems we might face when implementing this framework. First, management could resist due to the high upfront costs, as these expenses may impact short-term budgets. Second, extended review processes could delay development timelines, which may create pressure to rush certain stages. Recognizing these challenges allows us to prepare mitigation strategies in advance. In summary, our integrated safety governance framework combines feed-forward, concurrent, and feedback controls to address Boeing's safety governance gaps. By applying this approach from concept to post-delivery, we can detect and resolve risks earlier, improve communication across departments, and build a stronger safety culture. Ultimately, this will restore trust with regulators and the public. That's all for our group video. Thanks for listening.